Okay, so in this lesson, we're going to learn how to graph piecewise functions. And now remember, in a previous lesson, we saw how to evaluate piecewise functions. So remember, in the previous lesson, we're given these piecewise functions, and you had to evaluate these piecewise functions at particular values for x. Now remember, when we did that, like over here, when you want to find f of 4, you had to first of all determine, remember this says x is 4, you had to first of all determine which of these domains you would use, which of these domains 4 is located in. And then you would evaluate at one of these functions that are listed, okay, one of these pieces. All right, so go back and review this lesson before continuing on to graphing piecewise functions. Now, when we graph, I just want to remind you this was shown in a previous lesson. So notice that when we graph these piecewise functions, they're going to look like pieces of graphs, like parts of graphs. All right, so in the past, when you graph functions, they look like this. They were either lines or they were parabolas that look like these. Okay, notice one piece, a continuous function. Here, a continuous function, one piece. But now we're going to look at piecewise functions. So these are functions made up of different, so to speak, pieces. You have this that looks like a line, although it's not, it's a ray. Remember, a ray, you have an endpoint and an arrow. You have this that looks like a parabola, but it's part of a parabola. You don't see any arrows there. And again, you have another ray, although this is an open circle. So we're going to talk about when do I use open circles, when do I use closed circles as well. Okay? All right, so before we go on, I just want you to notice that, see this function here, how you had three different pieces? You have three pieces. All right, so when we do this, when we graph these piecewise functions, you're going to graph each one individually for that domain. Okay, so notice that this right here is actually this graph for that domain. This right here is this graph for that domain, and then from 2 to infinity, see how we go from 2 to infinity? X is greater than 2. That's the graph for this piece of the function. All right, and so notice that over here there are two parts of this function, so two pieces, and notice I have two pieces of graph, two parts of this graph. This part here, this part here, so that's the graph of this function, which is made up of two pieces. Okay? All right, so, and also notice that this is open, this is closed. That's going to be important. All right, and that's going to be based on whether you see an open circle, whether you see an equal sign, or whether you don't see an equal sign. Here's an equal sign, here's one that doesn't have an equal sign. Okay? All right, so it's not that difficult. It's fairly an easy thing to deal with. You just have to remember that this is linear, this is linear, this is quadratic, this is linear. All right, so what we're going to do here is just focus on linear and quadratic functions, because that's really all we dealt with at this point. Okay, so let's go ahead and look at our first example. All right, so graphing piecewise functions. So this is going to be our first one. All right, so number one, f of x is going to equal, and here's my piecewise function. It's going to equal the linear function 2x minus 1. Remember, this is linear, so it's important you know what this part of my function looks like or is. It's a line. But I'm restricting my domain, so I want to look at this part of the line in which x is less than or equal to 3. Okay, that's going to be important. And then if x is greater than 3, I'm going to use this one, x plus 4. So you're going to notice that when I graph this, there are going to be two pieces of this graph. That's all it is. All right? Okay, so here's the way I would do this. I would first of all look at the first part of this function, the first piece. So my first piece is this. So I'm going to graph f of x equals 2x minus 1 if x is less than or equal to 3. Let's do that first. Okay? Now, let's do a t-table. Do a t-table. Now, remember, This is linear. To graph a line, how many points do you need? You need at least 2. Okay? All right, now here's the way I would do this. You can't just pick any 2 points though, like we normally did. So remember when we graph this line here, I could have used any 2 points because my domain was all real numbers. All right? And so I could use any 2 points. But I can't do that any longer with a piecewise function because they're telling you what domain you can use. I can use any number for x that's less than or equal to 3. So in other words, I cannot use a 4 because 4 is not less than or equal to 3. If I used a 4, I would have to go here. And that takes us back to what we did in the last lesson, which was on this. So depending on the value of x, you have to determine which of these it applied to and pick the function that was needed. Okay? All right, so again, when graphing a piecewise function, you do each one individually. Okay, now, here's the way I would do this. I would always use the number that you see here. Use that number. Always, even if you don't see an equal sign, use it. Use it. Okay, so the number I see is 3. I'm going to use a 3. So wherever I see the variable x, I substitute 3. Okay, so when x is 3, remember fx is y. What's my y value? All right, well, I get 2 times 3 minus 1. So that's 6 minus 1, which is 5. All right, so I have 3, 5. Okay, now, before I do another point, remember to graph a line, these are linear. To graph a line, I need 2 points, right? Well, remember, I can only use values for x that are less than 3. So I can't use any number greater than 3. So let's say 0. If x is 0, because 0 is less than 3, right? So can I use 0? Yes, you can use 0, because 0 is less than or equal to 3. So I'm going to get 2 times 0 minus 1. So that's 0 minus 1, which is negative 1. All right. So I have 2 points. So let's plot that part of the graph. All right. Now here's where you have to be careful. When we graph a line, when we graph this line in previous courses and up to this point, you saw you had these 2 arrows, right? Okay. All right. Now watch what happens. I'm going to plot the point 3, 5. And make sure you printed this. This is part of that resource that's in Canvas. So just make sure you printed this, or you have your own grid because you need to practice with these. Okay, so I'm going to plot the point 3, 5. So 3, 5. All right. Now notice I put a closed circle here, and you're asking, well, why do you put a dot? Okay, so you see, I told you earlier to make sure that you use these numbers that you see. Always use this. Use this. Use that number for both this function and that function. All right, now you see there's an equal sign here. So what I would do here is now remember, as long as you're using this, you're going to say this is going to be closed. That's going to be closed. And that's going to bring us to the discussion of when is it closed, when is it open? When is it closed? When is it open? That's important. All right. Then I plot the other point, 0, negative 1. All right, so 0, negative 1 is right here. All right, so I'm going to put a dot there as well, a closed circle. All right, now here's where students mess up. When they, remember, and you're right, this is a linear function, okay? But it's a this whole thing is a piecewise function. So if you draw a line like you normally would do, it's incorrect. It's incorrect because you're saying that the domain of this function here is all real numbers, and that's not true. The largest x value is 3. So you got to do this now. You remember I started here. I started with 3. So you do 3. Put your little pencil point here. Oops, did not mean to smear this. But put the pencil point here. Align it with this point, and then do this. And there's your that piece. Now that's not supposed to be there. And that's that piece of this piecewise function. So what you did was you graphed a ray. Okay? So remember, parts of line is considered a ray. So instead of drawing the whole line here, we're restricting to the domain. I'm only looking at this part of the domain, so now we're looking at array. Okay, so this is a ray from geometry, ray or AY that I'm drawing. Okay, now that's this part of my function, my piecewise function. Now let's look at this part. Okay, now listen to the discussion. Now we're going to graph f of x equal x plus 4 if x is greater than 3. Okay, so again, use this number. Even though you don't see an equal sign, use this number. All right, now remember, this is linear, so to graph a line, I need at least 2 points. So I'm going to use 3. Now remember, though, I'm using 3, right? But is 3 greater than 3? The answer is no. 3 equals 3. So when I plot that point, that's where you're going to do that open circle. Because that point is not on this graph, but it's on, when x is 3, it's going to be on that graph. All right, so whenever you see an equal sign, it's a closed circle. Whenever you don't see an equal sign, you're going to use an open circle. Okay? All right, so it's going to be open because there's no equal sign here. No equal sign. All right, so when x is 3, you say 3 plus 4, and that's 7. All right, so what happens is this. Now look. So you remember you did x equal 3 and x equal 3, right? So when x is 3, you had this point, closed circle. And for 3, 7, which is here, you can have an open circle. Make it look open. See how I made it look open? All right, so I get that. All right, now I need one more point. Now I've got to use a number that's greater than 3, though. It's got to be in this domain. So let's say 4. If x is 4, I get 4 plus 4, which is 8. So I'm plot the point 4, 8. So 4, 8, which is here. Close circle. And then all I do is I start here, because I started at 3. And I draw my ray. So notice, that's the graph. This right here is the graph of this piecewise function. So this piece is a graph of this, and this piece is a graph of this one. Okay, notice when I did this, I used 3. Even though it's equal here and not here, I used 3 in both cases. This one was closed because that was an equal sign. This one I'm going to use an open circle because there's no equal sign here. So this point not part of this part of the graph, but when x is 3, you're going to use this point. This point's part of this graph. Okay? All right, so notice that these were lines. So don't draw a line. See, what some students do is this. So let me just show you real quickly. Remember, you're graphing a function, right? So what some students do, like for this one, what they'll do is this. They'll do, and then all of a sudden, just extending this like this, just doing this. But remember, that's no longer a function because it fails the vertical line test. So it can be that. These graphs cannot overlap because it's no longer a function. Okay, so this is incorrect. All right. So just make sure when you're graphing linear functions that they look that you're actually graphing rays. All right. Now open circle, closed circle. Okay. All right. Let's look at number 2. All right, number 2, let's suppose we had this. G of x, number 2. G of x is equal to 3x plus 2 if x is greater than 0. And I'm sorry, let's make it, I'm using the wrong one. If x is less than -1. Okay, x is less than -1. And then -5 if x is greater than or equal to -1. Okay, so notice no equal sign and equal sign. So this is going to be an open, this is going to be a closed. Okay, all right. Now remember what we did. You're going to graph each one individually. So you're going to graph them in pieces. So let's graph g of x equal 3x plus 2 if x is less than -1. Okay, all right. So you can always use this number now. Use this number. Even though you don't see an equal sign, use that number. So when I do a t-table, remember this is linear still. So I'm going to use -1 and I'm going to be open. So when I plot that point, it's going to be an open circle because there's no equal sign. So I've got to use an open circle. So when x is -1, I'm going to say 3 times -1 plus 2, which is -3 plus 2, which is -1. So I'm going to plot the point -1, -1, but remember, make sure it's open. So it's a good idea to put the word open there so you remember that. So -1, -1, right here. Notice I'm putting open circle. Okay, that's open. I need one more point to graph this ray. Remember, it's going to be a ray. All right, I got to pick a number that's less than -1 though. So like -2, all right, or -3, whatever you want to do. So let's say -3. So if x is -3, I get 3 times -3, so y equals 3 times -3 plus 2. 3 times -3 is a -9. -9 plus 2 is a -7. All right, so I'm going to plot the point -3, -7. Now, what you may say, was it going to be open or closed? Well, remember, -3 is part of this domain. -3 is less than -1, so that's going to be closed. So it's going to be just so you're just plotting that point like you normally would do. So -3, -7 is here. See, closed circle, a little dot. And then remember, don't draw a line that goes like this, because remember, this piece of the graph, you're starting here. And then you draw your line going through this point. And so there's your ray. All right, so that right here is the graph of the first piece of my function. Now let's look at this one. All right, so with the other one, now we're going to graph y equals, g of x means the same thing as y, -5 if x is greater than equal to -1. All right, so I'm going to use my t-table. This is still linear. And so I'm going to use -1. Notice this is equal sign, so I'm going to use closed now. See how I use -1 in both of them? All right, whatever this number is here, you can use it in both of them. One will be open, one will be closed. So that's going to be closed. So when x is -1, let's think about this. If x is -1, remember this says y always equals what? Y equals -1. So if you were to actually graph this, that would be a horizontal line. If the domain was all real numbers, that would be a horizontal line. All right, so remember, y is -5 here. So regardless of what x is, y, remember, this says y always equals -5. That's what that means. All right, but I got to pick numbers that's in this domain, starting with -1. So if -1, when x is -1, y is -5, and that's closed. I got to pick another number here, so you got to pick a number that's greater than equal to -1, though, to be able to graph this. So if y is, if x is, let's say, 2, what's y? Well, y is -5. And remember, all you need are 2 points. So now we're going to graph this. So -1, -5. All right, now remember how you're going to do this. -1, -5 is here. That's going to be a closed circle, and make sure it looks closed. So if you, make sure your open circle looks open and your closed circle looks closed. Sometimes when you use a pen, like I'm doing, sometimes it bleeds, and so it looks like it's closed when it actually is you meant it to be open. All right, and then the next one is 2, -5. 2, -5, which is here, and then you just draw, starting here, this. Now don't draw a line that goes like this, because you remember that's no longer a function. This for each of your functions, for each of these pieces, you're starting with x equal -1. That's what that is. So notice I started with x equal -1, plotted my point. I started with x equal -1, plotted my graph. All right. Now this is a graph. Don't forget your arrows here. There's supposed to be an arrow. So this is the graph of this function. F of g of x equal 3x plus 2 if x is less than -1, and then -5 if x is greater than equal to -1. So notice I have 2 pieces here. This part of the graph goes with the top one, and this part goes with the bottom one. Okay? All right, number 3. Let's do another one. Okay, number 3, let's suppose we had this. Number 3, we had h of x equal x plus 2 if x is greater than or equal to 0, and then x minus 2 if x is less than 0. All right, so again, we're going to graph each piece individually. So let's graph y equals x plus 2 if x is greater than or equal to 0. So I'm going to graph the first one. All right, now remember, I got to use these numbers. I got to use 0 because that's what I see. Okay, but then you're going to ask yourself, all right, it's going to be open or closed. Well, there's an equal sign here, so when I plot that point, it's going to be a closed circle. Okay? All right, so when x is 0, 0 plus 2 is 2. That goes here. All right, I need one more point. So I got to pick a number, though. I got to pick an x that's greater than or equal to 0. All right, so it has to be 0. So whatever I choose has to be greater than or equal to 0. So let's say 2. If x is 2, I get 2 plus 2, which is 4. All right, so I'm going to plot those 2 points. Let me try and find a grid. All right, so I'm going to plot those 2 points. And when I do that, all right, so the point I'm plotting is 0, 2, and 2, 4. So 0, 2 is here, closed circle, and then 2, 4 is here, closed circle again. And notice, though, you got to start at x equal 0. So you're going to start at this point here, okay? Start at this point and then go through here. So that's going to be array. Now don't draw a line now, okay? Because then when you draw the other one, you do the same thing. It's no longer a function. Okay, so you gotta graph. You have to graph what you're dealing with here in terms of this domain. So you're really, instead of graphing a line with those 2 arrows, you're actually graphing a ray. You're graphing part of a line. And so all you do is go this way, like this, and then draw your arrow. So you see you have a ray. Okay? All right, now let's look at the next piece. So the next piece is this one. So you're going to graph y equal x minus 2 if x is less than 0. All right, so in doing that, you're going to use 0, okay? But there's no equal sign, so what do when I plot that point, what will I use since there's no equal sign? If you said an open circle, you're correct. So write the word open. Write the word open there. So if x is 0, notice what I have, though. 0 minus 2, which is negative 2. So that means this. That means when I go to plot that point, 0, negative 2, which is here, what do I put? Do I put a closed circle or an open circle? You put an open circle, like this. Okay? All right. And then I need one more point, though. I got to remember this function is when you graph h of x equal x minus 2 in your strict domain, you're graphing a ray, not a line. You're graphing a ray, which is part of a line. So I need one more point, but it's got to be whatever value of x I choose, it's got to be in this domain. So let's say x is negative 2, because negative 2 is less than 0. So I get negative 2 minus 2, which is negative 4. And again, you could have chosen any value of x that's in this domain. I just chose negative 2. I'll plot that point, negative 2, negative 4. Negative 2, negative 4, which is here, closed circle. And I draw my ray, like this. All right. So notice when I list this function, it was h of x equal x plus 2 if x is greater than or equal to 0. That was what? That was this one. Okay. So this right here is this one. Part of a ray. Part of a line. So it's a ray. And then the other one was x minus 2 if x is less than 0. And that was this one. All right, so 2 pieces, 2 pieces. Okay, so notice, don't make both of those closed because that would no longer be a function, right? So remember, you're saying both have closed. Remember, you're saying that when x is 0, I have 2 y values. And remember, the definition of function says that for each x, there's got to be 1 y. So this is my y value right here. Okay, make sure you understand that. So listen to what I just said. Okay, so if I ask you what is h of 0, is it, remember when x is 0, is it 2 or is it negative 2? All right, so it's the one that's closed because that's the part of the graph that corresponds with 0. This is open. And even you could have gone here. If x is 0, which one do I use? Do I use this is 0 in this domain or is 0 in this domain? Well, it's not here because this says 0 is less than 0, and that's not true. 0 equals 0. And so notice 0 plus 2 is 2, and that's what this is. All right, so what I'm trying to say is don't make both of these closed, because you're then saying that when x is 0, y is 2 and a negative 2, which is no longer a function. Okay? And you're graphing a function here. All right. Now finally, let's look at this one. So this is going to be number 4. Number 4, you have f of x is equal to x plus 3 squared if x is greater than or equal to negative 3, and then x minus 2 if x is less than negative 3. Okay? All right, now, again, notice though that this right here is quadratic and this is linear. Okay? So the point being this. Now you all know that when you graph the linear one, that's going to be a ray. But you may wonder, well, what is this one going to look like? Well, let's do some points and see what we get. All right, now remember to graph a ray in all of these. How many points did I use in each one? I used 2 because it was part of a line. All right, and that's all I needed. But remember when we graphed these parabolas before. Remember I did the vertex, I did the y-intercept, and then I used symmetry and so forth, right? Remember we had done like 5? We had plotted 5 points and used the axis symmetry to help us. Renee, it's not going to be that much involved here, but it's, you got to, in your mind, think about what that graph looks like, okay? All right, now listen carefully. Here's the way I would do this. This is going to be the more difficult one to deal with. The linear ones are easy. It's this one. All right, so let's graph y equal x plus 3 squared if x is greater than or equal to negative 3. All right, now, in your mind, here's what I want you to think. You all know what this graph looks like if the domain was all real numbers. So remember the vertex, if you looked at this, y equals x plus 3 squared, the vertex would have been negative 3, 0, right? And so the parabola, since this is 1, a is positive, the parabola, negative 3 zeros here, the parabola opens up. So that's what this parabola, if the domain was all real numbers, would look like. Now that's not what this piece is not going to look like this though, but it'll be part of this. This will be part of this. All right? All right, so here's what I would do. Remember, you got to use this number here. So when x is negative 3, notice there's an equal sign, so it's going to be closed. All right, so wherever we see the variable x, I'm going to substitute negative 3. So I get y equals negative 3 plus 3 squared. Negative 3 plus 3 is 0. 0 squared is 0. Hence, remember the vertex? That's what you see here. Okay? So let's pick another number for x. So I got to choose a number though that's greater than negative 3, greater than or equal to negative 3. So let's say negative 2. If x is negative 2, I get y equals negative 2 plus 3 squared. Negative 2 plus 3 is 1. 1 squared is 1. So I plot the point negative 2, 1. Now here's where you're going to make your mistake. You're in all the problems we've done, you've only needed 2 points, right? So what you're going to do, what some of you are going to do is this, and I'll put it in the bottom one. You're going to say, I'm going to plot the point negative 3, 0, which is here, close circle, and I'm going to plot the point negative 2, 1, which is here. All right. Oh, I'm sorry. Here, I'm sorry. Right here. And then you're going to do this. Well, that's not true, right? Because that's a ray. That doesn't look like part of a parabola. Remember, a parabola looks like this. All right, so don't make that mistake. So what I'm trying to say is this: when you're not careful, and you overgeneralize based on what you've done before, you're you're um, you're going to make your graph look incorrect. So remember when we graphed parabolas in a previous lesson, we used at least 5 points. So what I'm suggesting, or what you need to do rather, is use another point. So give me another point that's greater than or equal to -3. Let's say 0. So if x is 0, I get y equal 0 plus 3 squared. Well, 0 plus 3 is 3. 3 squared is 9. So I plot the point 0, 9. And so now look what's going to happen. I'm going to do it on this one now. See how we messed up here? Let's do it on this one. So -3, 0, close circle. The next one was -2, 1, close circle. And the next one was 0, 9, which is right here. And look, here, remember that parabola is supposed to look like a parabola? If I draw it, let me draw it a little bit better. That's what you have. And isn't this piece right here, look, isn't this piece right here, this part, right here? So if the domain was all real numbers for this, then you would just do this, and you see that would be your parabola. All right, so that right here, this right here is this piece of my function. Okay? All right, now don't make a mistake and continue on like this, because then when you draw the other one, it's no longer a function. All right? So remember, you only graphing this if x is greater than or equal to -3. So x is greater than or equal to -3. Okay? All right, let's do the other. All right, so now we're going to graph y equal x minus 2 if x is less than -3. Now remember, this is linear, so this is going to be array now. All right, that's going to be array. And all I need are 2 points. See, I need at least 3 points here. I just need 2 here. All right, so I got to use this, -3. But remember, there's no equal sign, so I'm going to use what word? Open. All right, if x is -3, I get -3 minus 2, which is -5. And then I need one more. I got to pick a value for x that's less than -3, though. So let's say -5. If x is -5, -5 is less than -3, so I can use it. I get -5 minus 2, which is -7. And I plot those 2 points. So -3, -5, though. Now remember, here's -3, -5 right here. Don't make it closed, because it was closed for this one. It's got to be open for this one. And then the other one was -5, -7, which is here, closed. And then you draw your ray, starting here, going like this. And there's your graph. So when I look at my function, and that was f of x equal x plus 3 squared if x is greater than or equal to -3. I'm running out of room here. So that's this one. Okay, that is this one. Remember, don't do this, because you see it will fail the vertical line test. That's no longer true. So when you graph the full parabola, that's only true if the domain's all real numbers, but you're restricting the domain. You only want to look at the part of the domain that's greater than or equal to -3. So that's the one you use. When x is greater than or equal to -3, this is the graph. And the other one was x minus 2 if x is less than -3. And that's this one. So when x is less than -3, this is what you get. Okay? All right. So that's going to take care of those 4 problems. So that should basically give you an idea of how to graph piecewise function. Remember, the piecewise functions we're going to have, the piecewise functions we're going to deal with will either be linear. So when you graph them, be parts of a line. So these will be rays. See, these are linear. So when you graph each restricted domain, it'll be a ray, open circle or closed circle, whatever it may be. But remember, you must use those numbers you see here when you do your t-table. And you may see one that's a quadratic. All right, but that's about, and it'll look like this. It won't be a difficult one. but it'll be an easy one to deal with. All right. So if you understood this, if you can do something like this, you'll be fine with what you need on a quiz or a test. All right. So it's going to take care of this lesson, which dealt with graphing piecewise functions.